Good day once again, grade 12s, and welcome back to yet another video on the anti-science theory. So in the previous video, we looked at an introduction to chemical equilibrium, an introduction into what we call reversible reactions, the Chatelier's principle, and all in a nutshell, what chemical equilibrium is basically all about, and how different and the types of factors that basically affect the equilibrium position, right? So that I just want us to focus on each factor that affects equilibrium position. Just want us to go deeper into each of these factors. The first factor I want to look at is temperature. Now remember that with temperature we'll look at two types of reactions, that is your exothermic reaction as well as your endothermic reaction. Endothermic reaction. Right. So in grade 10, no, in grade 11, in grade 11 you guys learned about did you did you guys not learn? I swear you guys learned this in grade 11, 10 as well. Anyway, in grade 11 you learned about these two types of reactions, right? You learned about the exothermic reaction as well as an endothermic reaction, right? So, what you still should remember is that with an endothermic reaction, the change in enthalpy is always positive, right? And with an exothermic reaction, the change in enthalpy is always less than zero. Similarly, you could say that is negative, and here that is positive. Cool. Now, temperature can be a very um well, not that I mean it's not complicated, but it may seem complicated. But with proper with a more deep understanding into what basically happens with chemical equilibrium, especially when we focus on the factor of temperature, if you can like try to understand what basically happens with that, it becomes quite easy. But that is also what I need to make sure that happens in this video. I need to make sure that you guys understand just how much easy this thing can be. Okay, so consider a reaction, like any type of reaction. Say I'm looking at a reaction between let's see, trying to think of a reaction. Yeah, well, let's just take this type of reaction. So consider a reaction between um uh nitrogen, nitrogen dioxide, um to then give me, remember these arrows, remember what they mean, then give me dinitrogen tetroxide, N2O4. Okay. By the way, this is a gas, and this is also a gas. Is our equation balanced? No, I have two nitrogens. I just need two more right there. Now it's balanced. Okay. Now, so I have a reaction like this, which, by the way, is an exothermic reaction. So this reaction that we have here is an exothermic reaction. Remember what we know about exothermic reactions? We know that with exothermic reactions, our change in enthalpy is less than zero. Very important point. Okay, so this system is initially at equilibrium. Please keep that in mind. The system is initially at equilibrium. Then I decide to introduce a disturbance. But before we introduce a disturbance, let's basically talk about what happens here. Since I have an exothermic reaction, what do you remember? Remember that with an exothermic reaction, by definition, it is a reaction whereby your change in enthalpy is less than zero. But another thing that I want you to talk about is the fact that energy is released, heat energy is released from the system. So that would obviously mean that if something is released, basically what you produced at the end, or you just released, think of that as something. When you release something, it's basically like a product, right? So your heat energy will be on the product side. It's the first thing I want us to talk about, right? So we have the heat energy on the product side. Okay. Now, I then introduce a disturbance. Now, let's say the disturbance that I introduce, I say I decide to then increase the temperature. That's my disturbance. I increase the temperature. What happens? When I increase the temperature, remember when you increase the temperature, you make something more hot. Or, yes, it becomes hotter than it initially was in the most basic sense. So you're basically increasing the heat, right? So you increase the temperature, you are increasing the heat of something. So in essence, when you're increasing the temperature, you are increasing the heat. Now with that, now that you're increasing the heat, now remember what I said in the first video. If you have not watched that video, please make sure to go and watch it before you watch this one. What I said was that with a minor introduction on the Chatelet's principle, whatever you decide to do to a system at equilibrium, any type of disturbance you decide to introduce, the system will re-establish equilibrium by favoring the reaction that will counteract your disturbance. So what was my disturbance? I increased the temperature, which as a result increases the heat. What does the system do to counteract my increase? Remember, that's my disturbance, increase of the heat. My disturbance was increasing the temperature, which as a result increases the heat. So I increased. What does the system do to counteract the disturbance? The system will decrease. And in order for the system to decrease, it needs to favor the reaction that will decrease the amount of heat. So instead of going in that direction, whereby if I go in that direction, I'm basically adding more heat. But that's not what the system wants. The system wants to do the opposite of what you've done. You've already added heat by increasing the temperature. So the system will try to counteract your heat by decreasing the temperature, right? And in that way, the reverse reaction must be favored. So it will then favor the reverse reaction. Why does it favor the reverse reaction? Because you had increased the heat. You had increased the temperature, rather. And as a result, when you increase the temperature, you end up increasing the heat. So, with an increase in the heat, equilibrium then says, no, no, no. We do not want you to increase the heat. We want to do the opposite of what you do. When you increase that heat, we will do the opposite. And our opposite is to decrease it. When we decrease the heat, that means we need to favor a reaction that will use up or produce or to decrease that particular heat. And that is when we will then favor the reverse reaction. And as a result, what happens? When the reverse reaction is favored, the heat will then decrease. Remember, that was the goal. However, because heat is a product alongside the N2O4, both of these things must decrease. It can't be a thing you go to only one of them decreases. Both of them must decrease because they are both products. If there was something else on the reactant side, then both those reactants would then increase or decrease. It's not just one thing because they both play a major role in what's going on the other side. So when I decrease the heat, I automatically decrease N2O4 and then I increase the nitrogen dioxide. Therefore, after that has been done, equilibrium will then be re-established. Now, in case you're wondering, doesn't it mean that if I now increase this thing, I've created another disturbance? How do I fix that issue? No, 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 ladies and gentlemen, listen to me carefully. You only focus on one disturbance, or rather one factor, and whatever you decide to do, you need to focus on the effect of one product or reactant or element or molecule. For example, I was talking about temperature increase. That means I only affected heat. You only focus on heat. Once equilibrium has undone what you did in terms of the heat, that then equilibrium will be reestablished. It's not a matter of saying, for example, if I decrease the heat, if I increase temperature, which increases the heat, when I favor the reverse reaction, that will obviously decrease the heat. Oh, nice. But then again, it increases NO2. So that's another disturbance. That means I need to go back to the forward. No, you only focus on one thing only. Do not decide to just confuse yourself by trying to think what happens as a result. If NO2 increases, doesn't that mean that's another disturbance? No, it's not another disturbance. It's just the resulting effect. What happens at the end once you've reestablished equilibrium? Right. I hope we're all clear on that one, right? So what happened? We increased the temperature, which basically increased the heat. And as a result, equilibrium will reestablish by having the system favor the reaction that will counteract your disturbance. And in this particular case, we increased what is on the product side. That's what we did. We decided to increase what is on the product side. To counteract that, we need to go in the reverse reaction, in the opposite direction, and that is away from my product and going back to the reactants. Remember when we covered that in the first session? When I move from products to reactants, I am going in the reverse direction. When I'm moving from reactants to products, that is in the forward direction. So in this particular case, I increase the temperature of what? I increase the temperature, and that as a result increases the heat, which is on the product side. So to move away or to decrease on the product side, I need to go back to my reactants, and that is in the reverse direction. As a result, the system will favor the reverse reaction. Right. I hope that was very clear, ladies and gentlemen. I really hope that was clear. Right. Okay. So, let's see what happens when we decide to decrease the heat, the temperature. So now I decide to then decrease the temperature. With my exothermic reaction, I'm now decreasing the temperature. What happens? When I decrease the temperature, okay, let me just remove these things here. Okay, so what happens when I decrease the temperature? Obviously, when you lower the temperature of something, you make it more colder, right? So you lower the heat. So in essence, if I increase the temperature, what I'm basically doing, oh, no, 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 not decrease. When I decrease the temperature, not increase, when I decrease the temperature, what happens? As a result, I decrease the heat. Now notice something, ladies and gentlemen. When I decrease the heat, something happens. Something happens. When I decrease the heat, what did you do? You decrease the heat. How will the system re-establish equilibrium? The system will re-establish equilibrium by favoring the reaction that will counteract your decrease. So instead of decreasing the heat like you did, the system will decide to increase the heat. And in order to produce more heat, you need to move in the forward direction. Why? Because heat is a product in this case. So if you need to make more of your products, then you need to move in the forward direction. Therefore, in this case, the system will then favor the forward direction, or the forward reaction, sorry, the forward reaction. So the system will re-establish equilibrium by favoring the forward reaction. Right. Okay. That is a very important thing to understand, ladies and gentlemen. Very, very important, this one. It's very, very important. I really hope that was very clear in terms of temperature, which, oh, what just happened? What just happened? What just happened? Okay, there we go. In terms of the temperature, because it can be a lot can go on here, really. So it's very important for you to understand what happens when you look at um the factor of temperature. Okay. Now, what I want you to think, to know is that an increase in the temperature, right, favors an endothermic reaction. An increase in the temperature favors the endothermic reaction. Endothermic reaction. And a decrease in the temperature favors the exothermic reaction. Favors the exothermic reaction. So these are two very important points, ladies and gentlemen. Very, very important points. Now let's see what that basically means. Now, if I say to you, remember now in this point, in this era of the Ford reaction, that was when we had a decrease in the temperature. So that was when I decreased my temperature. What did we say? We said then a decrease in the temperature favors the exothermic reaction. Now, if you focus on this thing, notice that what did we first do? We established that when I decrease the temperature, I'm basically decreasing the heat. And the equilibrium, the system will then reinstate equilibrium by favoring the reaction that will counteract your disturbance. So instead of decreasing the heat, the system will decide to increase it. So remember, heat in this case is a product. So in order for me to increase or make more of my products, I need to use the reactants by going in the forward direction. So the forward reaction was favored. But keep in mind what we just said, ladies and gentlemen. We said a decrease in the temperature favors an exothermic reaction. So as a result, since in this case you favored the forward direction when you decrease your temperature, you can then conclude that the forward reaction is exothermic. Right, let me explain that once again. When I decrease my temperature, I decrease the heat, right? Then the system will re-establish equilibrium by doing the opposite of what you did. You remember you decreased. So the system will increase. And in order to increase the heat, which is a product, it will then favor the forward reaction. Why? Because if you're decreasing the product, in order for the system to increase it, it must use up my reactants to form more of my products. Thus, if I'm using reactants to go to products, that is in the forward direction. And as a result, the forward reaction was favored. However, like I've just added, that if you decrease the temperature, you favor the exothermic reaction. So as a result, since you favor the forward reaction, then you can conclude that that particular forward reaction that you favored is thus an exothermic reaction. So if you favor the forward reaction, you can then conclude, why did we favor the forward reaction? Because we decreased the temperature, thus decreasing the heat, which is on the product side. And so, in order for the system to reestablish equilibrium, it will favor the forward reaction, right? So that it can use the reactants to form more of my products, thus increasing the heat. And since I favored the forward reaction, what did I say? I said a decrease in the temperature favors the exothermic. Since you've already favored the forward reaction, you can then conclude that the forward reaction is exothermic. And as a result, the opposite is true. That means the reverse reaction must be endothermic, basically. So that also tells you that the reverse reaction is endothermic. Just to put that to the test, ladies and gentlemen, let's go back to the part where we decided to increase our temperature. When I said I'm increasing the temperature, I'm going to try and use a different colored arrow to avoid confusion. When I said I'm increasing the temperature, what did that mean? That meant I'm gonna increase the heat, right? That means I'm gonna increase the heat. And if I'm, no, that means I'm gonna increase the heat. Okay, that means I'm gonna increase the heat. What is going on? So that's my increase in the heat. How does the system reestablish equilibrium? The system will reestablish equilibrium by favoring the reaction that will decrease the heat. And obviously, if I need to use up my products, I can use the products to go back into the reactants. Therefore, in this case, that would be in the reverse direction. So in that case, what just happened? In that case, the reverse reaction was favored. Now, remember what we said. When I increased the temperature, I favored the reverse reaction. What else did we say about an increase in the temperature? We also stated that an increase in the temperature favors an endothermic reaction. And since in this case, the reverse reaction was favored, that then tells you that the reverse reaction was endothermic. Right. I really hope that was very clear with you guys. I hope, I really, really do hope that was very clear. But I'm gonna do another example just to make this a bit more clear than it initially is, hopefully. So this time I'm gonna take an endothermic reaction. Okay.